this is Romy speaking, and today we're going to talk about Classiq platform. So this is our website that you can access at platform.classiq.io. In this website, you can go throughout all the levels of development, from modeling, where you can model and focus on the high level of the problem and the algorithm that you want to do. And then you can synthesize and send it to a quantum circuit that implements this high-level algorithm. Eventually, you can execute it, where you can choose where you want to run on each of these many simulators. Eventually, once you run it, you get some result, you get a histogram of the results. Okay, so now let's dive into each of these steps. So in our example, we're going to focus on Grover algorithm, which is an algorithm that gets a problem and finds a solution for this problem. It's a search problem algorithm. Specifically, we're going to use Grover for 3-set. So we get a 3-set CNF, something that we're looking for an assignment that gives true value for the CNF expression. More specifically, we get this expression. So we can go through it together and very easily see that there are only 2 valid assignments out of 8. These 2 must hold that x0 is 0, because here we have not x0 and x1 and not x0 or x2. So here we see that x0 must be equal to 0 and x1 must be equal to 1. And then x2 can be either 0 or 1 because this part is already 1. Okay, and here we implement Grover algorithm and we use 7 iterations for Grover. Okay, now that we're done, we can click here to synthesize, but let's please note the right side of our screen. Here we can choose on what we want to optimize. So right now, we're not optimizing on any of the parameters, but we can optimize on the depth, which is how many sequential gates we have, or the width, which is the amount of qubits that we use. Right now, let's just stay like this and synthesize our circuit. Okay, so what's happening now is that the synthesis engine finds what's the best circuit implementation for our algorithm. And the synthesis engine is done, and it gives us this algorithm. We can see that we have here 7 iterations of our Grover operator, and at the beginning we have some Hadamard transform. And we see that we have only x, which was an array of 3 qubits that we operate on, and then eventually we measure. But we can also expand this view and see all the qubits that there are, and we can expand each of these blocks and see how it's implemented. Okay, so now that we've seen the algorithm and the way that it was implemented as a quantum circuit, we can move on to execute it. Here we can choose where we want to execute it, on which hardware or simulator we want to do it. So now we're going to focus on this simulator, and we click run. Now we're going to run on this Google simulator and see what we're getting. Remember that we have 8 different assignments, and out of these 8 assignments, only 2 are what we're looking for. And luckily enough, or not, the algorithm gave us exactly 2 answers. As we can see here, it's only a bit string that it's hard to parse and understand. So when we go over the histogram, we can see the counts that we have that got us the result, where x is an array that the first place is 0, then 1, then 0, which was x0 is 0, x1 is 1, and x2 is 0, which is okay. Remember, we wanted 2 assignments that only x2 is free to be either 0 or 1, but x0 must be equal to 0 and x1 must be equal to 1. And this is exactly what the algorithm gave us, these 2 solutions. So we were able to model our problem and focus on the high level of what we want to do. Then we're able to see how it's implemented and see here how many qubits we used. And we were able to choose where we want to run this circuit. Eventually, we were able to run it on this hardware or simulator and see what the algorithm eventually gave us. And that's it for today, folks. See you next time.